Hi, my name's Lindsay Moyer, and this video is for the Udacity Mentor Program for the Data Analyst Nano Degree. And what I thought I would do is go through my journey in terms of achieving this DAN degree, because I think it's important when people look at this, they understand what they're getting into and how they can be prepared, and to also keep the objective in mind, which is obviously to get a job and be successful in the data science field. So first of all, let's talk about preparation. If you're going to be successful in this program, you do need to know how to program Python. There are some people that can come into the program and learn programming and learn Python, but I think those are the exception. If you want to be prepared and you want to be on top of the program, you should learn Python before you get into this program. So I've learned 5 languages before. They're PL1, COBOL, Fortran a long time ago, and 2 assembly languages. And I decided that I had to learn Python up front. So what I did is I actually learned by a book called Learn Python the Hard Way. Udacity has programs for this, and there are also other free resources on the internet. Bottom line is learn Python and learn it well enough that you're comfortable with it. So that's the first thing. Once you get into the program, keep the objective in mind, which is to get a job when you get out as a data analyst or continue on into data science. But what you should do is use Git. Now, unfortunately, I didn't use Git, and I wish I would have, but Udacity, again, has a great program on Git. And once you get out, you need a place where you can show what you've done, and Git is a perfect place to do that. You will be asked over and over again during the potential interview process or during the job application process, do you have anything on Git? You might as well just get over it, learn how to use Git, and get your applications on there. This is a little bit of a problem when you're starting out, because you don't want to expose your, quote, lack of skills to the world, but just get over it. You'll get better, and look at it as an archive of learning for yourself. So those are a couple of things. Now let's get into the program. The first thing you'll do is you'll actually do the weather trends application. That's going to be in Excel, and that's fairly straightforward. Just compare your city's data to overall global climate changes. So if you're comfortable with Excel, not too difficult. The next one is really where the rubber hits the road, and this is probably the hardest project that you'll do in the first semester, which is the bike share program. Initially, there were over 10 million rows in that application that Udacity gave us. It literally crushed my machine. Most other people in the program had the same problem. They took that data set and they cut it down to about 300,000 rows for each city, much more manageable. But you will have to use Python in there, and if you're not comfortable with Python, it'll be difficult. It's tough to keep up with this program unless your skills in Python are reasonable. Don't have to be great, you don't have to be a really accomplished programmer, but you have to be comfortable with the language. So in that program, you will actually have a template where they tell you how to format the comments at the beginning of each function. So this will be a template that you should use in your programming as you move forward. The inputs, the outputs, what the actual function does. So that's the bike share program. And the other thing you need to be aware of is you're going to be having this reviewed by reviewers who are used to people not considering all of the potential ways that you can screw up the input into this. So in other words, you're asking end users to give you some simple instructions, and end users always do things oddly. So just be aware that before you submit the program, you should spend some time on debugging and testing what potential odd things can go on with a user as they input to the system. So that's the bike share program. The next one that I did was descriptive statistics, and I used the European Football Association. I also used Python on this, still using Python, and Matplotlib and I also used SQLite, so we did use some SQL in there. And there were a lot of graphs, and the purpose was to, basically describe this data set, and then from that draw some insight. I also did some correlation coefficients using Pearson and Spearman at the end of it. It was kind of an extra that I did for this particular project. But remember, you're trying to build a body of work here that you can show potential employers how good you are. So doing extra work, doing that extra little bit, making it look good, putting it up on Git is how you're going to get a job when you get out of this, or it will help greatly. So after that, we did something called A/B testing. We used Pandas for that in Python. So Pandas is a set processing technology that allows you to apply an operation to all of the columns, for example, in a data set. And this is a very standard way of manipulating the rows and columns that you commonly see in these data sets. So Pandas makes it a lot quicker, a lot easier to work with, and not nearly as much programming is required with Pandas. You don't have to have as many for loops, for example. So A/B testing is when you want to make a change to the website. You're not sure whether or not it's going to actually encourage the key performance indicator that you want, which might be increased traffic, it might be click-through rates, and it's a way of scientifically proving that either the null hypothesis is correct, which is no difference, or the change is beneficial to the key performance indicator that you want. So this is the type of program that is commonly asked for in industry. Anybody that has a website will probably be doing A/B testing, or should be doing A/B testing, and having this as a project that you can show somebody should be quite helpful to your career. The next thing that we did was something called the Stroop effect. Now, the Stroop effect we did this in, let's see what we did this in. We did it in Python, Pandas, and Matplotlib again. But it's an interesting project in that it shows you how data can describe what we do in everyday life in a very realistic way. So the Stroop effect has to do with congruency bias. If I look outside and I see the trees moving, I know it's windy. I don't have to go out and measure the wind. Where you might see a bad example of the Stroop effect is a police lineup where supposedly one person in this lineup is the perpetrator of the crime. Well, we've got a congruency bias. If the police show us a lineup, we assume one of the people in there must be the bad guy. So quite often we'll choose one, and we're not absolutely 100% sure, but we'll tell the police we're 100% sure. And all that we were doing is we're just being congruent. Police showed us a lineup, the perp must be in there. Guess what? We choose one, and quite often we've gone ahead and chosen a person that had nothing to do with the crime. So it's interesting to see that in the data and see it, shown in graphs and shown how hard it is to fight the Stroop effect. So that's what you'll do in this little program. The next one that we did was using R. I did a red wine data set, and after it was all through, I built a linear model. It was actually a multiple variable linear model, and it predicted something that was just like me. It had never met a bad bottle of wine. So you will be using R in this program. R is a very common language to use for statistical analysis. There's a lot of work outside in the job world for R. It has ggplot, which is a very capable plotting package. I personally don't like R as much as Python. I find Python to be a lot more elegant, and the world is definitely going to Python, but R is a very good tool to have in your toolkit as a data analyst. The next one that we did was Twitter data wrangling, and this is a complete pipeline. It's extraction and transformation. You don't really load the data in this case, you simply describe it. But you use the Twitter API, you hit the net for these pages, they come back in JSON format. JSON is a nesting format. It's a dictionary of dictionaries. You'll see this commonly in industry. It takes a little while to get used to it, but once you're used to it, it's quite easy to work with. And this was almost like a capstone project. You had to use Python, you had to use pandas, you had to use descriptive statistics, you had to explore the data, you had to analyze the data. It's a good project, and it's kind of fun because you were using something called @dog_rates, which is where people rate their dog, and of course there are no bad dogs, and there's lots of hilarious dogs and dog photos. So that was a fun project. So the next thing that we did is we did a Tableau project. So the way the market's going, you have to understand in data science right now, this is an emerging area. A lot of the techniques have been around, depending how you count, certainly in computer science for 40 years at least. But statistics is a couple hundred years old. Machine learning, I think the original papers on it are at least 20 years old. That's in terms of neural nets, but might actually older than that, come to think of it. Machine learning's been around for a long time, but we didn't have the computation platforms until recently to really take advantage of it. So anyways, what's the point? The next one is something called Prosper, which we use Tableau for. So the idea was take a data set. The one I chose was the Prosper data set. That's a peer-to-peer a peer-to-peer lending organization that's based in the States. And what they do is they take people who want to lend money to other people, they consolidate them and provide a platform for doing that. And this was to have you use Tableau on it. And Tableau is a very elegant program. It's an example of these tools that take a lot of the work that you would do in Matplotlib or ggplot and simply make it very easy and straightforward. So you should learn Tableau, and it puts a lot of pizzazz to your storytelling and to your ability to tell the story that you are a competent data analyst. But it also is indicative of what's going on in this area. More and more of the software that's coming out is automating the process of being a data analyst or a data scientist. Tableau is a good example of that. The things that are proving very hard to automate and always have been hard to automate are actually the data wrangling parts. And 80 to 90% of a data science project, even if it's a machine learning project, is in the data wrangling. So what's the point? The Python skills are the one thing that is proving very, very hard to automate. So the Data Analyst Nano degree provides you a solid basis for that. So just keep this in mind as you go through. A lot of the higher end bits in machine learning, etc., you can actually automate fairly quickly, but it's very difficult to actually automate the data wrangling. And when I say you can automate the higher end machine learning parts, I mean the feature engineering, the algorithm choosing, et cetera, et cetera. There's still a lot of understanding you have to have about how to do that, but that's much more susceptible to automation than the actual job of extracting data and manipulating data so that the data set is usable in a machine learning context. So that's what I've been up to. Post that, I've actually been working on something I call Moonshot Genius, which is taking social media data and combining it with stock market data and see if you can come up with predictions of stock price movement. There's one that I did on the S&P 500 that had a 0.56 R-squared value. That's quite high. That's quite good. And there's another one that I did with social media on low price stocks that has about a 0.45 R-squared value, and that's still pretty good. So I'm just working on that. So my plans currently are to take the data scientist nano degree, complete that hopefully by August, September of this year, and then just continue on. Anyways, thanks very much for watching this video. I hope I have the opportunity to be a mentor for Udacity.